Hey guys, in my last video I showed you guys how to calculate the mass percent composition of a compound if you knew its formula. Now we're going to go the other way. Okay, let's say we know the mass percent composition, but we want to find the empirical formula. Here's how you do it. First, so you're going to be given the percent of each element in the compound. Just change those percents to grams. So you're going to have how many grams of each element you have in the compound for a total of 100 grams of the compound. Next, convert those grams to moles, and to do this you just divide by the molar mass of that element. Next, so you're going to have numbers, moles of each of the elements. Whichever is the smallest number of moles from step number 2, divide it into the others. I'm going to do an example in a second and this will be clear hopefully. Now once you do step 3, if you get all those numbers and they're closer than 0.1 to a whole number, just round each of those to a whole number, and these will give you the subscripts in the empirical formula, which gives you the empirical formula. So let's do a little example. Let's suppose we're told that we have a compound that is 52.14% carbon by mass, 13.13% hydrogen by mass, and 34.73% oxygen by mass. What's its empirical formula? Okay, so hopefully you wrote down those steps and just follow through as we do them. So step 1, convert the percents to grams. So we just change the percent sign to a G, really. 52.14% carbon means 52.14 grams of carbon. You see, what we're doing here is we're saying, okay, the mass percent is true no matter how much of that compound you have. So why don't we say we have exactly 100 grams? That means that if we have 100 grams of the compound and it's 52.14% carbon, then there's 52.14 grams of carbon, you see? And then now we change the percents to grams for hydrogen and oxygen. That's step 1. Step 2, change the grams to moles by dividing by the molar masses. So 52.14 grams of carbon divided by 12.011 grams per mole. Now, I got this number by just looking up carbon on the periodic table, and I read its molar mass right from there. And so I do that division, I get 4.341 moles of carbon. For hydrogen, when I do the same thing, I get this number, 13.03 moles of hydrogen. And for oxygen, get 2.17 moles of oxygen. So each of these numbers here I got from up here. The numbers in the denominators I got from the periodic table for that element. Alright, so now we know how many moles of each element we have. Now we're just going to divide by the smallest. Of these three numbers, 2.171 is the smallest. So we're going to divide this into these other two, just like this. Oops, there we go. So 4.341 moles of carbon divided by 2.171 moles of oxygen gives us 1.9995 or so moles of carbon. Now look at the units. This is actually pretty important. That's moles of carbon for every 1 mole of oxygen. Doing the same thing for hydrogen, we get 6.0018 moles of hydrogen per every 1 mole of oxygen. Both of these numbers, 1.9995 and 6.0018, are closer than 0.1 to a whole number, and so we're just going to round these. And that'll give us our subscripts. Watch. So it becomes 2 moles of carbon for every 1 mole of oxygen, 6 moles of hydrogen for every 1 mole of oxygen, and that gives us our empirical formula. The 2 is a subscript for the carbon, 6 is a subscript for the hydrogen, and oxygen is 1, and so we don't write the 1. There we go, one of my favorite molecules, ethanol.